welcome to this talk. I'm so happy, we are so happy to be here, and we will talk about the JavaScript ecosystem. We will go through the front end, the mobile, the back end, and the AI, of course, because right now AI is everywhere. So my name is Giorgio. I'm a senior engineer at Qwik. I'm open source contributor. I'm a core team member of Qwik, maintainer of different libraries, and I am also Microsoft MVP. My partner in crime for this talk is Fabio.
Yes, hi all. I'm Fabio. I'm full-time front-end trainer, especially focused on Angular and React ecosystem, but I love more or less most of the front-end technology currently in the market. Okay, so let's start. In 2015, we have 6, the language has been completely rewritten and changed, adding new syntax and feature in order to create a more powerful language and flexible. The introduction of latent const offered more control over variable context. Arrow function made the code more concise and help to handle the this, for example, in classes. I don't think we need to say how much convenient is now to use imports and modules. So every year we have a lot of utilities and tools for improve arrays, object promises, regular expressions, and so on. So every year there are many proposals for the introduction of new language feature, and before being confirmed, they pass several phases of staging. So there are some interesting features that I want to show you. For example, the first revolution I want to show you is the new immutable tuple and a record. A record is more or less an object, but it's not an object, because a record is an object. Is not an object, but a deeply immutable primitive value. And the tuple is more or less the same. Even if it's not important, the most important feature, there is one thing that surprised me positively. For example, equality of records and tuples works like JS primitives. I mean Boolean and string. What does it mean? It means that now we can do this equality of record and tuples works like primitives. It means that we can compare some object by content and not by identity. In my opinion, this is a revolution. Okay, what do you think? Okay, another cool proposal is the pattern matching. You can think to it just like a super switch, where the match is just like switch, when is just like the case, but the interesting part is that when can contain a complex condition and some logic. It's very interesting. I think it's very interesting. We'll see if it will be approved. And another interesting proposal is the pipeline operator. Should improve readability and reduce parenthesis cell in deeply nested function call. I'm not sure if I like it. Do you like it? Insomma. Okay. This is weird. This proposal introduces an API to propagate values through asynchronous code, such as promise continuation or async callbacks. In this example, we can track the time running a function in an external module after, for example, a click of a button. And when asynchronous code is complete, we can call another method in the same module and retrieve the value, update it, without the need to pass properties between functions. Okay, and I'm not sure if I like this too, but we'll see. And I love RxJS, but probably we'll never see RxJS 8, currently is the 7 version, and probably because observable will become part of the JavaScript language. Okay.
For talking about TypeScript and Go, I would like to pitch the fact that Microsoft recently changed the build system, and in the new releases, we will have a build system on top of Go. Why Go? Because Microsoft decided to do a porting one by one from TypeScript to Go. So in the end, Microsoft decided to share with the community this kind of timing, run the Go compiler against this repository. So, for example, VS Code from current 77 seconds, right now with the native, it's a little over 7 seconds. This is really cool, and I was really happy because one of these repository is type ORM. I'm a maintainer of this repository, so it was really cool to see my work and our work inside of the Microsoft announcement.
Exactly. And but the truth is that we are still fighting to load the page as soon as possible. And it seems that most of the front-end frameworks today are working to improve it and are focusing on it. The goal is to improve the user experience as much as possible. For example, why we should wait 2 seconds to load and see something in this page. There are strategies that we can put in action by simply using native HTML functionalities in the correct way to improve this behavior. But when we use front-end frameworks or UI libraries, it's more complex than this. So I think there are 4 main problems. The first one is SEO, especially in the case for website. Speed, so I mean the loading time of the page. User experience, which often is translated into conversions. So the higher is the load time, the more user we lose. So we lose money. So the core web vitals the core web vitals help us to monitor the quality of our website. I'm talking about some metrics that Google offered to understand if our project is correctly configured, and it works fine. For example, time to first byte, even if it's not an official metric, allow us to understand if the server responds slowly, or first and large contentful paint allow us to understand how much time the page requires to load some kind of content. Time to interact, interaction to next paint, how much time the page requires to become interactive, and so on. And Chrome DevTools has greatly improved in this year to analyze our application, offering not only the result, but also a lot of tips to improve it. Here you can see Lighthouse, for example. I think that all of you know this tool. But since Lighthouse requires some time to analyze the site, we can also use the performance tool, always available in the Chrome Web Tools, to quickly analyze in real time some values. For example, here you can see that when you navigate the site, you can see large contentful paint, cumulative layout shift, interaction to next paint, and so on. And this panel has also been improved and simplified. This is very useful when you want to understand what's happening behind the scene. I also suggest to take a look to web.dev website because there are interesting news in these days about this panel. Anyway, we have a lot of tools to analyze our website. For example, not a lot of people know Chrome UX Report Dashboard that also is useful to analyze core web vitals, but over time, months after months. Or the recent Qwik or Cracks Viz that give a quick stats about your metric. We also have an npm package, Core Web Vitals, that we can integrate in our project to monitor this value during development, and website, just like page speed, several others. So, how can we improve the performance? Of course, we can create a website like this, and probably we won't have any problems with Core Web Vitals. It really works. But probably we want to improve the UI, add some feature, make something more cool than this. So this is the reason why we often use front-end framework that offer and help us to create complex UI and improve performance. And the main effort we can notice in the latest year of this framework is that they are focused to improve all the rendering strategies and new rendering strategies. So let's analyze the basic concept first to make a quick recap. The client-side rendering is often used in single-page application when we create something in Angular, React, and so on. When the user visits the first page, the server returns an empty HTML file. The UI is not created until most of the JavaScript code is loaded. For example, we have to load Angular, React, and our custom code. The UI is created, but there is no content. So we make one or more HTTP requests, we get some JSON from the server, and the UI can be rendered. This process is very long, so performance are often poor, and SEO is also bad since the HTML is initially empty. Using server-side rendering, the mechanism is completely different. User requests a page, the server can make some queries to the DB on file system and so on, and returns an HTML page with all the content. The difference with static site generation and incremental site regeneration is just that the page is pre-rendered at build time instead of runtime, just like in server-side rendered. Anyway, in both cases, the page is still static, and the interaction are not allowed until the JavaScript is loaded and all event handlers are attached to the DOM. This process is known as hydration. I simplify it, but more or less, this is the process. In fact, it's not enough to apply a correct rendering strategy to improve the performance. The amount of JavaScript we are using in our projects is increasing every day, and this can make some metrics of the core web vital worse. The higher is the amount of JavaScript, the higher is the loading time of the page. And not only this, more time is required to the page to become interactive. So latest frameworks are trying to improve this process, the hydration. First, let's understand how hydration works. When we use server-side rendering or static generation, the server loads a pre-rendered page, a pre-rendered version of the page. In this way, the content is visible as soon as possible. After that, Angular, React, or any other framework is loaded. All the JavaScript necessary for the page is loaded. And what it does, it recreates a client-side exact copy that must exactly match what the server generated. At this point, the hydration occurs, which is the mechanism, as I said, that attach all JavaScript listener to the HTML page. And only after all this process is finished, the page can become interactive. Okay. In this animation, you can see a preview of this process. It loads first the HTML and CSS, and then all the JavaScript, and the page becomes interactive. But therefore, there are new strategies that are emerging to improve the hydration. One of these is the progressive hydration, just like you can see here in the animation. Instead of waiting for all the JavaScript to be loaded, parts of the page can be loaded based on different strategies. For example, by identifying the key element that must become interactive before other, assigning, for example, some priority, or when we scroll the page based on media queries, and so on. And in the latest years, Angular team worked hard to improve performance and the developer experience, doing a great work. And they also worked on server-side rendering and hydration. For example, now it's very easy to create an Angular application with mixed rendering. I mean that we can simply define which route should use client-side, server-side, static generation. And there are also new hydration strategies to enable what they call incremental hydration. In few words, we can hydrate component based on some rules, just as I said. For example, when we click an element, when we scroll, and so on. Another interesting part is the event replay to keep track of user interaction. For example, a click, some keyboard events, and so on, before the hydration complete. So these events are not lost and can be replicated when the hydration complete. And React, especially Next, popularity grows every year. And probably is now one of the most used full-stack framework to work both with client and server side. The architecture based on client and server components allow you to define what should run completely on server and what needs the client-side JavaScript in a granular way. The use of suspense allow you to create a kind of HTML streaming where we give some priority to some content that needs to be loaded first. And we can postpone those components that could slow down the rendering of the page. So they define it as sort of a kind of HTML streaming. And Astro, I love Astro, is an amazing framework, and they are also working on this, probably before others. For example, what I like of Astro is the performance that are great, probably the best performance you can have using a front-end framework, especially in a static page, because when you have a static page, you load zero JavaScript, zero, nothing. The idle architecture allows us to define how iteration should work. Here you can see, for example, here that a React component can be iterated, for example, when the page is visible. In this case, just like in Angular, we can define to load the component iterate a component based on media query, scrolling, and so on. And as you can see, the nice part of Astro is that you can mix several frameworks in the same page. For example, you can have a page with a React component, an Angular component, a Svelte component, a Vue component. It's not the best choice, but it works. And recently, honestly, I didn't try it, but recently they also introduced a new concept called server island. And this means that, for example, a server island could be a component that is connected to a legacy backend and won't delay the rest of the page from being seen and interactive with. Probably it should work just like the suspense in Next, but I have still to try it. Okay, and Qwik. I think that Giorgio is the best person to talk about it since he's a core maintainer. So
Thank you. Thank you. Let's talk about Qwik. I'm a core team member of Qwik. We mentioned before that Astro can integrate React, Angular, Svelte, and other frameworks. And when you integrate them, of course, you need to load JavaScript. With Qwik, we are doing totally different things. We are approaching the problem in a different angle. So basically, we are doing a server-side rendering, and we are shipping only HTML and CSS, only 1 kilobyte of JavaScript, and we will see why we need this kilobyte of JavaScript. And then we are basically waiting for the events from the outside, basically from the user. So we are waiting, for example, a click from a user. So when the user click on the page, we shipped only HTML and CSS, as we mentioned. We have inside of the HTML, the server, during the compilation, did an optimization and included this kind of a non-standard HTML syntax, like on, column, click. This means that the framework is able to say, okay, the user clicks on a button, we need to execute the JavaScript that is needed for the specific action. So we are not running all the JavaScript up front. We don't have the problem of the iteration. We are simply shipping HTML and CSS like the old website we saw before. So the core web vitals are 100% for all the categories. And with this system, you are able to execute only, as I mentioned, the JavaScript needed. So if you have a lot of external libraries, you are paying them, you are paying the fact that you are executing the JavaScript only when you are using a specific part of the application. So it doesn't matter if you have a big application or a small one, you will only ship HTML and CSS and 1 kilobyte of JavaScript. So it's scaled really, really well. And this system is called resumability. So basically, the user calls the server contacts the database, and the server ships the page with info, and we saw before the on column click. And With Qwik, basically we have the component boundaries. So the optimizer under the hood is grabbing all your JavaScript and is creating these special chunks to be able to be so fast and immediate. So in the page we have event listener and so on and so forth. So we will have in these days another specific talk for Qwik. So I don't want to spoil you too much. So let's move on to micro frontends. We can't mention, talking about the JavaScript ecosystem, we can't mention micro frontends. With Qwik, it's really easy to do micro frontends even without any kind of library, because we saw that HTML and CSS has inside all the information needed. So you don't need to include different stuff than just HTML and CSS. So in this case, we have a host that is holding, for example, two applications, one for the menu and the other one for the main part of the application. This kind of architecture is not for all the companies. I mean, this is useful when you need to scale teams instead of your company. You have a big application, you need to scale teams without any kind of communication intra-theme. So this is really useful when you have you need to scale your app. And with this application, with this approach, you can deploy independently all the part of the system. Talking about libraries, there is a Module Federation library. I'm the author of Module Federation Vite, but Module Federation organization cover a lot of bundlers like Vite, Webpack, and RESTpack is a porting of Webpack with Rust. And with this kind of library, we can use React, Vue, Angular, all the frameworks, and we can mix and match, like the Qwik example I showed you before. We can mix and match part of the application. So we can literally create a Frankenstein application if we really need it. Because if we need to do this kind of scalability, micro frontend is the way to do it. But micro frontends are not only for the web. We can use micro frontend on mobile because CallStack recently create a porting of Webpack into the mobile, and it's called RESTpack. And basically, we can do, as we saw before in the animation, we can load part of the applications inside of a mobile. So you don't have to deal with stores, so on and so forth. You can literally download on the fly part of the application and include them into your mobile app. Usually, mobile is based on React Native, but a few weeks ago, Lynx, the company, TikTok company, ByteDance, created this new framework called Lynx. It's a set of tools, from the dev tool to the bundler to the JavaScript optimizer, so on and so forth. You can look at this specific project because it's really interesting. TikTok is using it, so it's really great. Let's talk about backend. We have backend in JavaScript as well, and we have these three runtime. We have a Node. Back in 2009 was invented, and in 2016 there was a fork with a new stream of features. It's supporting JavaScript and TypeScript as well. Security part of a Node is not really great like the others, but you know, long-term support is something that it's really important. The Node team it's focused not on the performance, but it's focused on the security part, and also to not doing breaking change. The ecosystem is really great because a lot of projects are running on Node, so I think it's the right solution right now. Use Node.js for the backend. Because Deno was invented in 2018, TypeScript and JavaScript support. Security is something that is out of the box, because when you are installing something for Deno, if a package needs a post-install script, it's blocking all of this kind of life cycle for the packages. And also, if you are trying to access to a network, write a file, something like that, you need to specific allow this kind of operation. So if I want to write a file in my system, I need to specify, okay, this script specific can write on the disk. And this is security-wise really, really important. From Deno 2.0, sorry, right now we are in 2.2. And there is a long-term support also for Deno. The performance are quite okay. I mean, it's not the key characteristic. The ecosystem is not that good right now. There is some problem with other frameworks, but the use cases are not that great. But it's improving. It's improving day by day, weeks by weeks. And let's talk about Bun. Bun was invented in 2021. It's running TypeScript and JavaScript as well. On the security part, it's not asking you for a permission if you need to write something on a disk or read something from network. But if you have a package that needs to run a PostScript, for example, to install something, it's blocking this kind of system, and it's asking you to allow the install and post-install stuff. There is no long-term support with Bun. Performance are the key point, because is written in Zig, and it's on top of a JavaScript core. Node and Deno is on top of V8, but Bun is on top of JavaScript core. And the performance is the key point. If you are trying to use Bun, you should use it for this. The ecosystem, because it's really new, the ecosystem is not great at the moment. Use cases, there are a few use cases, but mainly focused on the performance. Okay, as mentioned, let's talk about AI. How many of you use AI in your work? Okay, I think most all of you. I can't see the other room, but I guess all are using AI. Yesterday, Meta released a new version of Llama 4. Models are using a context, a Windows context. So right now, the Windows context is not that great. So you can write inside of the prompt, you can write few things, not that much. But with the new release, with Llama 4, we have 10 millions of Windows context. It's really, really huge. You can imagine you can copy paste inside of the prompt 5 million of words. This means that in the future, I think extension, IDE, and the other tools are able to learn from the whole code base and not just from few files. This will be a great thing, I guess. The most important fact, I think, is the soft skill. So probably AI will replace some part of our work, some tedious part, but in the end, you know, AI has hallucinations. In the end, we need to have a focus on what we are doing and try to choose the right things to do. Even if the AI is spitting a lot of code, we don't have to copy paste from from Stack Overflow. We don't have to copy paste from AI and put the code inside of our project. But right now on Chrome, we are able, from I think the release 1.3.1 of Chrome, so last year, it's possible to use AI inside Chrome. So if we have a problem with CSS, we are not mastering CSS, we can ask for example, here, how can I make this element round? If you don't know how to do it, or you are a special guest like Massimo with CSS, or you can ask to AI and try to guess if is saying you the right things. But you can use AI on Chrome also for network requests. You can ask things about the network request, performance, and also inside of the console, if you have some errors, you can ask to AI to help you in this direction.